So I just want to take a second today to show you a little thing about calibrations between the NanoVNA V2 and a professional grade VNA, in this case an E5061B vector network analyzer. So I'm just setting up the sweep right here for the NanoVNA V2. It's 100 megahertz to 3 gigahertz with 30 points. And then I put a marker at 1.5 gigahertz, and I went ahead and I do a calibration for the NanoVNA V2. Make sure when you put your standards on, I'll be using a female calibration kit in this case. You don't spin female SMAs inside the male connector, spin the outside of the male connector, press it in, don't let the cable spin, and good to go. So go ahead and do an open, short, and a load real quick here. Hit done, and then save that into the calibration 0. And then look for the little C star D indicator, which tells us that we have a valid calibration in there. Then the next thing that I usually do, I go ahead and I make a sanity check, and I look for a load in the center of the Smith chart, 50 ohm dot, and then I look at my open circuit and I expect a dot in the right of the Smith chart for a open standard connected, and I expect a line looking like a negative length transmission line for nothing connected, and then a dot on the far left of the Smith chart for a short circuit. And I see exactly that, so it passes my sanity test. Now if I repeat the same process with the real VNA, something weird's going to happen. I complete the short open load calibration, and then I go to look at the 50 ohm load. It's dot in the center of the Smith chart, just like we expect. Now I unplug the 50 ohm load, and I have an open on the line, but no open standard connected to it. But I'm basically seeing dot where a negative length open circuit stub line should be. So I go ahead and I connect the open standard, and now suddenly I'm seeing something that looks like a transmission line is connected between that cable and the open standard. And if I repeat the process for short circuit, I'll see the same thing. It looks like there's an additional transmission line added. So the typical sanity check that we perform after we do a calibration on the NanoVNA V2 is that we look for 3 dots in the correct places on the Smith chart for open, short, and load, at least for a one-port calibration anyway. What's going on here that this is different? Well, Agilent defines a professional grade calibration kit, the 8033 Echo, which has standards that are non-ideal. There's some inductive parameters for the short here, and then there's also an offset delay and an offset loss parameter. But our NanoVNA V2 expects that we're using perfect calibration standards as opposed to some professionally spec'd out kit that's slightly different from the ideal case. The through standard also has the offset delay and offset loss parameters, but for this demonstration we're only doing a one-port calibration. So how do you fix this? Well, you just define a custom calibration kit on your professional VNA that assumes the standards that you're using are absolutely perfect. And this will give you measurements that are basically the same as what you can get on the front panel of the NanoVNA V2, or very close to it. And while they might not be as close to the reality of what the true measurement is, they'll at least agree with what you're measuring on the other device. So here I'll repeat the calibration procedure real quick with the perfect calibration kit defined in the E5061B VNA. And then we'll take a look at our standards and how they measure and see if they pass our sanity test that we typically use for NanoVNA V2 measurements. So with that calibration complete, let's check our load. Dot in the center of the Smith chart, very good. An open that isn't our standard looks like a transmission line of negative length connected to the end of the cable. Our open standard looks like a dot on the far right of the Smith chart. And our short standard looks like a dot on the far left of the Smith chart. So this should give us measurements that are pretty close to what we make on the NanoVNA V2 because we're using a calibration kit that looks the same to both devices. That should clear up any gross inaccuracies between measurements taken from a real VNA and the NanoVNA V2 using the same calibration kit. Just make sure that the two devices are interpreting it the same way. Now, I'm pretty sure that you can go and define custom calibration standards on the USB connections to the NanoVNA V2, but this is at least for a scenario where you're doing this from the front panel of the NanoVNA V2 and from the front panel of some professional lab instrument that you want to give you readings that are about the same, just so you're working on the same standards for whatever it is that you're doing. If you like this video, please press that thumbs up button. If you didn't, you know what to do. Just be glad YouTube's still counting those. If you're following me on other platforms like Library, Odyssey, or BitChute, don't worry, I'll get the message. Their dislike buttons aren't going anywhere anytime soon. Do remember to subscribe and go ahead and ring that bell if you want to be notified when I post more videos. Bye.